Okay, so next part is question type 2. So these type of questions are going to be about interpreting and using probability distributions that are given as charts. So the first section in this part is about blackjack again. So in blackjack, each player is dealt a starting pair of cards. The starting pair has a point value that can range from 4 to 21 points. The probability of each possible value is shown in the chart below. So here's the chart. And it has a lot of lines on it, sorry about that, but I tried to make it kind of as easy as possible to read. So along the x-axis here is the different possible point values for the blackjack starting pair. So the worst you could get is like 2 2s, so that's a 4 over here. And then the best you can do is a 21, which would be an ace and then a card that was worth 10. Okay, and then everything in between is also possible. There's a big peak on 20 because the face cards are also worth 10, so that becomes more probable than other things. And then over here on the left, the probabilities are labeled as fractions, not as percentages. That was to make it easier for you guys to read the heights of these columns here. Because if I do them as percentages, then you can't see exactly what they are because they would be rounded off. Okay, so anyway, what is the probability of being dealt a starting pair worth 21 points? So this type of question is pretty easy. You just have to look at the column for 21 points. So here's a column for 21 points. And then just read off its height. Okay, its height is its probability. So you're going to follow this line over here. If you can't follow a straight line, then get your pencil out and hold it against the paper. So it looks to me like that's 8 out of 169. All right, so 8 out of 169. All right. Question number 2 is not too much harder. So what is the probability of being dealt a starting pair worth 20 or more points? So here you have to make sure that you interpret 20 or more as meaning 20 or 21 points. Okay, and then from there you just look up the probability for each of those. So 20's probability is 18 out of 69. 21's probability is 8 out of 169. And then you just simply add those together. Okay, so that's going back to this probability formula up here in your table. When a series of events are mutually exclusive, the probability that one or the other or whichever of them happens, you get it by just adding up their probabilities. Okay, so all these outcomes here are mutually exclusive because you only have one starting pair. All right, so 20 or 21 points is the event that we're looking at. So the probability is... So you do probability of 20 plus probability of 21, and just read those off of the chart. 20 is 18 out of 169. 21, we already said in the last question, was 8 out of 169. So together that's 26 out of 169. But you don't need to simplify. You can just leave it like this. That's fine with me. Okay, number 3. When your starting pair is worth 11 points or less, the right strategy is to hit, which means ask for another card. What is the probability of being dealt a starting pair worth 11 points or less? So here, make sure you interpret 11 points or less in the right way. So 11 points or less means 11 or 10 or 9 or 8 or 7 or 6 or 5 or 4. Okay. So you're going to get the probability by adding up the probabilities of each of those events. All right, so you're going to do probability of 4 is 1 out of 169 plus probability, let me zoom out a little, plus probability of 5 is 2 out of 169. Probability of 6 is 3 out of 169. And it looks like they just kind of go up one by one. So probability of 7 is 4 out of 169. Probability of 8 is 5 out of 169. Probability of 9 is 6 out of 169. Probability of 10, 7 out of 169. And finally, probability of 11, it looks like 8 out of 169. So the easy way to add those up, of course, is put them all over the same denominator and then do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Okay, if you want to, you don't have to simplify it actually. You can just circle this and leave it like that. But if you do want to figure out the sort of final answer here, then get a calculator and you end up with 36 out of 169. And I never said what sort of format to put the probability in, so you can just leave it in whatever format you like, fraction, decimal, percentage, whatever. Okay, so next part here is about six-sided dice. So we're rolling 3 six-sided dice. So when you roll 3 six-sided dice, the sum of the dice can range from 3, that's if you get 3 ones, to 18, that's if you get 3 sixes. And then everything in between there is also possible. So the probability of each possible sum is shown in this chart here. So the smallest is 3 over here on the left, and then 18 on the right. So that's the possible sums for 3 dice. And probabilities are on the vertical axis here, and they're shown as fractions out of 216. So there's 6 times 6 times 6, which is 216 total possible outcomes for rolling 3 dice. So that's why they're all out of 216 like that. All right, so number 4 says, if you roll 3 six-sided dice, what is the probability that the sum is 10 or 11? So 10 or 11 are these middle two, the most probable outcomes. So their height is 27, they're both 27, okay? So 10 or 11, we're just gonna add these together. Probability of 10 plus probability of 11, 27 out of 216 plus 27 out of 216, which I think comes to 54 out of 216. All right. And next question. If you roll 3 six-sided dice, what is the probability that the sum is not 10 or 11? So for this one, you can use your not probability formula. Probability that an event does not happen is 1 minus the probability that it does happen. So we're just doing 1 minus the probability from number 4. So we're going to do, we're going to do 1 minus answer from number 4. Okay. So 1 minus 54 over 216. And I think, let's see, what's 216 minus 54? Sorry, just grabbed a calculator quickly. So that's 162 out of 216. Or you can just leave it unsimplified. That's fine too. Last one here. If you roll 3 six-sided dice, what is the probability that the sum is 6 or less? So we want to make sure we interpret 6 or less as 6 or 5 or 4 or 3. Okay, so 6 or less means 6 or 5 or 4 or 3. 3 is the smallest possible. So we're just going to add up those probabilities. I'm just putting the notation here just to make sure it's clear what I'm doing. And let's see, what are they going to be? So 10, 6, 3, and 1. Looks like 10 out of 216. 6 out of 216, 3 out of 216, and 1 out of 216. Okay, so if we add those up, let's see, 10 plus 6, 16, 19, 20, 20 out of 216. All right, so that is this whole section here. Question type 4 is interpret and reason about variability and standard deviation. Okay, so first question is 2 families. Family A consists of 6 people with the following heights in inches: 62, 64, 68, 69, 72, 74, 75. Family B also has 6 people with these heights: 67, 67, 68, 69, 69, and 70. Which family do you think has the greater variability in height and why? So all of you guys drew me a really nice little stick figure groups in class when I asked you to draw one with great variability and one with small variability. So the small variability stick figures, you drew pretty much all the same height. So this group right here looks a lot closer together in height to me. There's only a 3-inch spread. Whereas this group right here, there's a 13-inch range from the minimum to the maximum. And they're pretty well spread out in between there too. Like there's a gap of 2 here and then 4 between these two. 1-inch gap here, 3-inch gap here, 2-inch gap here. So yeah, there's more gaps between them. So I think it should be pretty clear that family A has greater variability because the numbers are more spread out from 62 to 75 versus from 67 to 70 in group in family B. Okay. Next question. A certain teacher has 2 classes with 50 students each. Each class completed a homework worth 20 points, and above are the histograms showing the homework scores for each class. So this is class left and class right, I guess, or class A and class B. Both classes have the same mean, which was 10. Which class had the greater standard deviation and why? Okay, so you have to be careful here. I'm not asking about the standard deviation of the column heights. I'm asking about the homework scores that produced this histogram. So if we look at the left histogram has the most common scores in the range of, or the intervals of, so the 2 highest columns here were from 8 to 10 and 10 to 12. So 8 to 10 and 10 to 12. And those are near the mean of 10. So looking at intervals further from the mean, they have fewer and fewer students in them. Okay, so like as we're going away from the mean on the horizontal axis here, you're seeing less students in each of those groups. There are very few students the furthest from the mean in 0 to interval or 18 to 20 interval. Okay, so that's the left histogram. On the other hand, the right histogram has no students at all, from 6 to 8 all the way to 12 to 14. So there's nobody close to the mean. All students are pretty far from the mean of 10. And the most common group is 0 to 2, which is really far from, that's the farthest you can be from the mean. So based on all that description, so the left one has the greatest number of students pretty close to the mean, the right one has no students close to the mean, everyone is far from the mean. It should be pretty obvious actually that the right class has the higher standard deviation. So the right class, or class B if you want to call them that, has the greater standard deviation because their homework scores are farther from the mean in general. Okay, number 3, picture below which group has greatest variability in size. Hopefully this one's pretty obvious visually. So in group A here, oh right, I put these in their own cells. Hold on, I'll type it up here. Okay, so in group A, all cats are the same size, so this is the least variability. In group B, there are some size differences, but not that big. So that's medium variability. Group C has large size differences. So they have a really, really big cat and they have a really, really tiny cat. So that has the most variability. Okay, hope that makes sense to you guys. Number 4 rather. I'm teaching 2 sections of the same class. Their average on the first test was the same, 80, but section A had a standard deviation of 5 and section B had a standard deviation of 20. So which section do you think had more D's and F's and why? Okay, so, and then which section do you think had more A's and why? Okay, so the standard deviation is telling us that class B had a more spread out scores and class A scores were closer together. So we don't know if they were like normally distributed or if they had some weird distribution, but class B was more spread out. So I would expect class B to have more students that were further from the mean. So students that got close to the mean would have gotten either like a C or a B. So if they were in the 70s, they would have a C. If they were in the 80s, they would have a B. So students who scored close to the mean would have a C or B, like 70 to 90, or 89, I guess, would be the highest B. Students who got an F, D, or an A are further from the mean. Okay, so I would expect actually class B would have more students further from the mean in general, so they would have more students with D's, F's, and A's. Okay. Lastly, polka dots, so very similar to the cat problem. Which group of polka dots has the most variability in size? So hopefully you can see this one here on the right has the least variability. So this group has practically no variability, almost zero variability, as they are all the same size. Okay, now between these two, which one has more variability? So what you want to look for is the mediums. This group B has no medium-sized dots. It only has tiny or big. This group A has some medium-sized dots, like this one or this one. So this one has some medium-sized dots, so it's not as variable as group B. So that one I would say the variability is in the middle. This group has no mediums. It's only got huge or tiny dots. So this has the most variability. Okay, so that was section 4, and now on to question type 5. Okay, so the first section here is about US states and territories. So there are 56 of those, and the population of each of them is shown in this table. The mean population for the states and territories is 5,920,674. Standard deviation 7,191,227. So the first question here, actually before I do the first question, I think I want to write down the mu and sigma values here below the table, just for my own reference. So mean mu is going to be this number, and standard deviation sigma is going to be this number. Okay. All right, and let's see. So now I can answer this question. What percentage of states and territories are within one standard deviation of the mean? So to figure out which ones are within one standard deviation of the mean, we need to go up and down one standard deviation from the mean. So you start at the mean, go down one standard deviation, and then start at the mean, go up one standard deviation. I decided not to give you guys this as like a formula because I think this is some kind of basic mathematical reasoning that you ought to be capable of. So within one standard deviation of the mean means one standard deviation above, or one standard deviation below, or in between those two things. All right, so I'm just going to take these two numbers here, subtract, take them and add them. So if you do this in the wrong order right here, if you swap sigma minus mu, you can get potentially wrong answers. So don't do that. And this is why you need a calculator, so you can actually figure out what these are. So let me pause and put those in a calculator. Okay, so here are the numbers that I'm getting. So the first one was negative, and the second one is pretty large. Okay, so we want to know what percentage of states and territories are between these two numbers. Okay, so first we need to count how many are between those two numbers. So starting with the smallest one, that's going to be between, and then going all the way up to 13 million and some. So these are in order like down the columns here. So 13 million, looks like it stops right here. Pennsylvania is actually the last one that is in that range. So it's all but these last four. Okay, so all but the last four, which is New York, Florida, Texas, and California, are between the two numbers. So that's 52 out of 56, or Let's see what it is as a percentage. 92.9%. Okay, so make sure that you recognize what you're being asked for in the question. This says what percentage. Some of these other ones say how many. So you need to distinguish between whether you're being asked how many or what percentage or what fraction or what exactly you're being asked. Okay, next question. What percentage of states and territories are within half a standard deviation of the mean? So again, we just need to figure out how far away is half a standard deviation from the mean. So you're going to start at the mean. Oops, sorry. You're going to start at the mean, go down half a standard deviation, and then you're going to start at the mean, and you're going to go up half a standard deviation, and just figure out what those two numbers are. So I'll just copy what I had up here, and then I'm going to jam my 1/2 in front of this one. Okay, and then same for next one, except I'm going to add these. All right, so now I need my calculator. Okay, so here's what I got, and these numbers should be within the range that you got on number 1 because you're not going as far away from the mean, so it makes sense that they're inside, like between these two numbers here. Okay, so 2,300,000 to 9,500,000. So let's see, we're gonna start, okay, 2, 3, looks like Kansas is the first one. And then we're going to stop at 9.5. So that's going to be 9.5, 9.5, 9.5. Yeah, Michigan is going to be outside of that range. So everything from Kansas through New Jersey is going to be in the range. So let me note that down. Everything from Kansas through New Jersey is between these two numbers. So that's okay, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 26. Out of the 56 states and territories. And if we do that as a percentage, 46.4%. All right. Next question, what percentage of states and territories are more than half a standard deviation away from the mean? So here what you have to do is recognize that this is the opposite of what was asked for in number 2. So we can just do 100% minus the answer from number 2. Okay, so more than half a standard deviation away is the opposite of within half a standard deviation. All right, so I'm just going to do 100% minus 46.4%, and that should be 53.6%. So no need to even count. And then last question, what percentage of states and territories are more than 2 standard deviations above the mean? So what we need to do is figure out what is the number that is 2 standard deviations above the mean. So you start at the mean, go up 2 standard deviations. And that is going to be, so copy paste these numbers here, mu plus 2 times, let's see, I think this was the standard deviation. Okay, put that in a calculator and you get, so let's see, so I'm going to do the multiplication part first for my order of operations. 7,1,227. All right, and then I'm going to add the 5,920,000. 674. Okay, and now I can copy paste. Oops, that wasn't the right number. Try copy paste one more time. Nope. Why you do me like this, Microsoft? Come on. Oh my gosh. Seriously, copy paste is a thing in the calculator. I don't know why it's not working. Okay, there we go. It normally does it if you just hit Control-C from, even if you don't highlight the result. Okay, anyway, so that is the number, the population that would be 2 standard deviations above the mean, but what we need to do is then figure out how many states and territories are more than that. So like even further above the mean than this. So the first one would be Florida, and then Texas, and then California. So Florida, Texas, and California are the only states or territories that are further above the mean than this. So 3 out of 56. 3 out of 56. 5.4%. Okay. The next section of questions is about math majors at SU. So there are 25 math majors this semester at SU. I really looked this up. The number of credits earned by each is shown below. So we have everybody from freshmen that haven't taken anything yet to seniors and super seniors. The mean number of credits is 85, and the standard deviation is 45.3. So first, number 5, how many math majors are within 1 standard deviation of the mean? So we got to figure out what's 1 standard deviation above the mean, what's 1 standard deviation below the mean. So start at the mean, go down 1, start at the mean, go up 1. Oops. All right, so we're going to do 85 minus 45.3, and we're going to do 85 plus 45.3. Okay, so these are the numbers that I'm getting. So we want to know how many, remember it says how many, not what percentage, just how many, are within 1 standard deviation, so that means between these two numbers. So 39.7, the first one, it's not going to include 39. It has to be above 39.7. Okay, so the first one is going to be 64. And then it's going to be 64 up through, let's see, where does this stop at? So 126 would be the last one. So that's going to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 math majors are between these two numbers. So it's going to be 64. I'm just going to type these in here for people who are reading the solutions, because they're probably going to get mixed up about that 39. 94, 95, 97, 108, 109, 116, 23, 26. Okay. How many math majors are more than 1 standard deviation below the mean? So 1 standard deviation below the mean is this number right here, 39.7. And so we want to know how many are even below that, like even further below the mean than that. So that's going to be all these ones right here. Oh, and actually including 39. So 0, 0, 18, 18, 32, and 39. So there are 6 even lower than that. So 0, 0, 18, 18, 32, and 39. Okay. And number 7, how many math majors are more than 1 standard deviation above the mean? So 1 standard deviation above the mean is this number, 130.3. And we want to know how many are even higher than that. So there are, let's see, 132, 133, 37, 44, 58. So that's 5 that are even higher than that. So that's 132, 133, 137, 44, 158. Okay, so there are those two. And the last question in this section, how many math majors are within 2 standard deviations of the mean? So within 2 standard deviations means between 2 below and 2 above. So 2 standard deviations below the mean, start at the mean, go up 2 standard deviations. That's literally what this says. It says mean plus 2 standard deviations. So that's up. And then down would be start at the mean, go down 2 sigmas. All right, so this is going to be 85 minus 2 times 45.3. And this one is going to be 85 plus 2 times 45.3. When you're doing this on your calculator, if you're using a 4 function like me, you have to be a little bit careful because you want to do the multiplication first. Your PEMDAS, order of operations, multiplication comes first. Okay, so that is what I'm going to subtract from 85. And then I can do the subtraction. So 85 minus 90.6, negative 5.6. And then for the second one, same way, I do the multiplication first. So I get 90.6 again, and then I'm adding that to, oops, sorry. Getting all discombobulated. Okay, there we go. So then I'm adding that to 85 this time. So 175.6. All right, and then I think everybody's positive, so they're at least above this number. And then 175, I think that's more than the max. So yeah, everybody is between those two numbers. So all 25 math majors are between these two numbers. All right, so that's the end of that section. Now on to question type 6, which is calculating z-scores from data values and data values from z-scores. Okay, so we have here 3 means and 3 standard deviations, one for the US, Canada, and Mexico, and it's their states, territories, or provinces. Okay, so we got 3 different data sets going on. So you got to distinguish which data set or which country you're doing the z-score within, or you're doing the data value within. Okay, so number 1, District of Columbia, DC, that's in the US, has 702,455 people. What is its z-score within the US states and territories? So if it asks what is the z-score, then you're going to use the z-score formula. So it's up here at the top, right here. I just haven't memorized because I've been teaching this class a lot, but both versions of the formula are up here at the top. So when you want the z-score, you use the one that starts with z equals. So it's going to be x minus mu over sigma. And so you have to be careful what are your mu and your sigma, because you have 3 choices, right? So your x is your data value, and that's pretty clear here. It's this number of people. And then the mu part, it's asking the z-score within the US states and territories. Even if I hadn't said that within part, I think you should be able to figure out that it means within the US states and territories, because DC is in the US. Okay, so we're going to use the US mean, which is right here. And then we're going to use the US standard deviation, which is right here. Okay, so you just chuck all that into a calculator, and you'll probably have to round off a little bit. So let's see. 702,455 minus 592,064. Okay, so we get that result first. Okay, and then we're going to put that, actually I'll do it on 2 steps here. Oh, not again. Come on, calculator. You used to let me Control C. Okay, and then on the bottom we'll have this number from before. Okay, then we're going to do that division, and we're going to round off. So we're dividing by 7,91227. Okay, so we're getting approximately negative 0.726. I'm going to always round my z-scores to 3 places, because that's what I'm used to doing for using the table. But on this part, I don't really care how much you round in general. 2 or 3 digits after the decimal is fine. Okay, next question. How many people would a Canadian province or territory have if it had DC's z-score? So we're going to reuse the z-score from this problem, and then we're going to apply that to Canadian provinces and territories. And it's asking how many people, so that means we want to calculate the x, the data value, from the z-score. So this is when you need that other version of the formula, which looks like this. Okay. So this time, the mu and the sigma that you're going to use is for Canadian provinces and territories, because we're asking about what would a Canadian province or territory be. Okay, so we're going to use the mu, is going to be this one for Canada. Okay, and then the sigma is going to be this one for Canada. Okay, and then the z value that I'm going to put in front of my sigma is going to be the one from the last problem, the one for the DC territory. By the way, did you guys know that DC has a greater population than a lot of states, but it's not a state? Kind of weird. That's my plug for DC statehood. Okay. All right, so now we're going to plug these in and just make sure, again, order of operations means the multiplication should go first. So 1, 6, 4, 1, 3, 9. I'm going to multiply that. I'm on a 4 function, so I'm going to multiply it by positive 0.726, and then I'll just do a subtraction to take care of the negative. Okay, so this is going to be 2, 8, 9, 1, 4, 8, 1 minus that. Okay. All right. So we're going to do 2, 8, 9, 1, 4, 8, 1 minus 3, 0, 2, 3, 1, 6, 4.914. Okay, and I got this. Okay, this doesn't make sense. What am I doing wrong? I got a negative population. Is that possible? Let me think about this for a second. I guess it is. I mean, it doesn't make sense because this is a negative number of people, so like we'd have to have zombies or something. Wait a minute. Yeah, I mean, I guess this is the right answer. Like, we didn't make any mistakes that I can find. But it just comes out weird because Canada's standard deviation is like a lot bigger relative to its mean than the US's standard deviation is. So yeah, like this low of a z-score was a positive population for the US, but that low of a z-score would actually be a negative population for Canada. So I guess we have a zombie province in Canada is the moral of the story. Okay, negative 131,000. I guess that means zombies. All right, whatever. Math comes out weird sometimes. Okay, so BC, first DC, now BC. British Columbia, or BC, has 5,071,336 people. What is its z-score within the Canadian provinces and territories? So we're calculating z-scores again. So we're going to use this formula, x minus mu over sigma. All right, and our x value is this number of people that we were given. And then our mu and our sigma, make sure you use the ones for Canada because it says within Canadian provinces. So we use this one and this one. Okay, and we're just going to chuck that into a calculator. I'm just going to go right to the final answer instead of demonstrating calculator order of operations. Okay, so I got 0.523. At least make sure that you got like the right sign. So BC has more than the mean, so it should be a positive z-score, which it is. Similarly for DC, it was less than the US mean, so it should have been a negative z-score, and it was. All right, how many people would a US state or territory have if it had BC's z-score? So since it's asking how many people, it's not asking for a z-score, it's asking you to convert a z-score back to a data value. So that's going to be this formula. Okay. And which mean and sigma are we going to use? So we're using the ones for US state and territories because we're asking how many people would US state or territories have. So this is the mu that we're going to use for the US. Z is going to be the same as in the last problem, so 0.523. And then our sigma is going to be US sigma. Okay, put that in a calculator, make sure you do the order of operations right, and you get... Okay, I got 9,781,685, which kind of makes sense because the US, like generally speaking, is more populous than Canada, so an equivalent in the US would typically have more population, unless it goes the opposite direction and they turn into zombies. So I guess like both weird things can happen. All right, so number 5 and 6 are about Mexico. So Veracruz, which is one of the Mexican states. By the way, did you guys know that Mexico is Los Estados Unidos de Mexico? Yes, they're also the United States of Mexico. So Veracruz is one of the states, and they have 8 million and some people. What is its z-score within Mexican states and districts? Okay, so we're going to use formula for z now because it's asking what is the z-score. So x minus mu over sigma. All right, so our x is the number of people. That's our data value. And then the mu and the sigma that we're going to use are going to be the ones for Mexico. So Mexican mu I think Mexico is bigger than Canada, so these numbers are a bit bigger. Okay, and I'm going to put that in a calculator, and it comes out to be, oops, I got 1.414. Veracruz is above the mean, so it should at least be positive. So that makes sense. Last question in this section, how many people would a U.S. state or territory have if it had the same z-score as Veracruz? So once again, we're being asked for the data value, not the z-score. So we need this formula for converting z-score back into a data value. And which mu and sigma do we want to use? So we're being asked about what would a U.S. state or territory have. So we're going to use the U.S. numbers. So US mu mean is here. We're going to use same z-score as for Veracruz, which was 1.414, and then the US sigma. So right here. All right, chuck that all in a calculator and you get, okay, so I'm getting 16 million and a little bit more than that. All right, so we're all the way at the last type of problem, question type 7, finding normal distribution probabilities. So this is the one where you actually need your table to look up the CDF values. But I'll go ahead and do as much as I can without the table, and then I will get the table out and show you guys as best as I can using the PDF how I would look up those CDFs. Okay. So 100 most popular songs on Spotify in 2022 had lengths that were approximately normally distributed with a mean of 3.4 minutes, standard deviation of 0.7 minutes. What is the probability that a randomly selected song from this list has a length of 2 minutes or shorter, 2 to 4 minutes, 4 minutes or longer? So all these questions in this section and also on the test are basically going to split all possible song lengths into 3 different ways that they could be. So it'll be something or shorter, something to something, and then something or longer. And then, I mean, they're not all song lengths. Like this one is beats per minute, this one is run times, but they all kind of follow the same pattern, not necessarily in the same order, but the same pattern, less than something, between something and something, greater than something. Okay, so what you need to do first of all is find the z-score for the 2 numbers. So the 2 minutes and the 4 minutes, those are your 2 numbers. You need the z-score for both of those, okay? So I'm gonna do that like outside of A, B, and C. So I'm gonna call this like Z1 and Z2. And they both have the same formula. I'm just gonna call X, X1 for the first one. You don't have to name your X's and your Z's if you don't want to, but I'm just gonna do it like this for folks that are reading these solutions instead of listening to me. So I think it'll be a little easier to understand what I'm doing if I get them names. Or maybe it would make it worse. I don't know. You guys tell me. So I'm going to calculate the z-score for the two data values that are of interest, which is the 2-minute song length and the 4-minute song length. Okay, so what I'm doing here is I'm putting in 2 for the first X and then 4 for the second X. But then other than that, the mean for both of them is going to be the same. So it was 3.4 minutes on average. So this will be 3.4 as well. And then standard deviation was 0.7. So put that there, put that there. Okay, and now I'm going to go ahead and take my calculator and figure out what these actually are. And I'm going to do it to 3 decimal places. That's for the sake of my table, because my table has 3 decimal places. Wait, does it have 3 or does it have 2? Oh my gosh, I think it only has 2. Let me double check that. Okay, I was misremembering and it has 2 decimal places on there. So you got to round all your Z's to 2 places. For some reason before I was thinking it was 3. So we need a much bigger table if it was 3. This one actually turned out to be exactly -2, so I went ahead and wrote 2 zeros there for the 2 places. So now what we're going to do is to figure out how many songs or what percentage of songs or what is the probability of a song being 2 minutes or shorter. What we want is the area under the standard normal curve. Area under the standard normal curve to the left of Z1. So that's the z-score for 2 minutes, which is -2.00. Okay, and that number, the area under the standard normal curve to the left of any z-score, is given by the CDF of that z-score. So the CDF of -2.00. So in a minute, I will get out the table and I will look that up with you guys. But for now, I'll just leave that as like, that's what we're going to do. This is our goal here. Okay, so for part B, what we want is, we want the area under the standard normal curve. So because we're looking between two numbers, we want the area under the standard normal curve between the two z-scores of z1 negative 2.00, negative 2.00, and z2, which is 0.86. Okay, and the way that you get the area between two z-scores under the standard normal curve is you look up the CDF of each of them, and you take the bigger one minus the smaller one. So in a minute, we will go and do that. And then lastly, for the area on the last one, what you want is, sorry, I'm getting a little slow on the bluing of these answers. What you want is the area under the standard normal curve to the right of the z-score, the second z-score, which is the z-score for 4 minutes. Okay, so the z-score for 4 minutes, we want 4 minutes or longer. That means we want everything to the right of that z-score. That's where all the bigger z-scores are. So to get the area under the standard normal curve to the right of a z-score instead of to the left, what you do is you take 1 minus the CDF for that z-score. So because you're doing 1 minus the area to the left, and the area under the entire standard normal curve is 1, that leaves you with the area that you want, which is that area to the right. So I'm going to put up a picture here in a second to show you guys kind of what it looks like. So give me a second. Okay, so here's a picture that I made for you guys of what it is that we're actually looking for. So here's the entire standard normal curve, and we assume that the Spotify song links are distributed with a histogram that looks similar to this. It looks approximately like this. So the z-score for 2 minutes is here at z equals -2. The z-score for 4 minutes is here at 0.86. So if you want to know what's the probability that a song lies between those two, you're looking for the area between those two. You want to know the probability that a song is less than 2 minutes, then you're looking to the left of that z-score. You want to know the probability that a song is longer than 4 minutes, you're looking to the right of that z-score corresponding to 4 minutes. Okay, so these are the 3 areas that you're looking for. And hopefully you guys can see that this orange area here for the last one is the opposite area from the area that would be to the left of z equals 0.86. So the area under the entire curve is 1, and then if we subtract the area to the left of z equals 0.86, that leaves us with this orange area over here. Okay. Similarly, that's the way it works with this one. We're subtracting the area to the left of 0.86, and we're taking that and we're subtracting the area to the left of -2. So we're taking this area to the left of this line, subtracting the area to the left of this line, and that leaves us with just what's in between here. All right, so now how do we actually look these up? Let me review that with you guys. Let me get my PDF out. Okay, so first we want to look up the CDF for -2.00. So I go to my table, and I'm looking over here for z. I'm going to look for -2.0. Okay, so here it is. So I'm looking in that line, and then my second decimal place is also 0. So I'm looking in this column that starts with 0.00. Okay, so I'm looking in this column and this row. So hopefully you guys can see where the column and the row overlap at is right here. Okay, so again, I'm looking in the row for z equals -2.0, and then up here at the top is where the second decimal place is indicated at. So if your second decimal place is 0, you're looking in this first column. If your second decimal place is 1, you're looking in this column. If your second decimal place is 2, you look in this column, okay, and so on. So I'm looking at this number right here, 0.0228. So 0.228, 0.22. So that means that the area to the left of this z-score of -2.00 under the standard normal curve is 0.0228. So that blue area right there is 0.0228. So about 2% of the area is under there. And it does look like a pretty small percentage of the total area, so 2% kind of makes sense to me. Now for the red, we already know this part. but we need to look up this part. So CDF of 0.86. So I'm going to look for the z-score here on the right, 0.86. So these are the negative ones. So I'm going to go to the other side. All right, so over here my z-scores are on the left, and I'm looking for 0.8. So here's 0.8. So I'm looking in this row. And then I want the second decimal place for 6, so I'm looking in this column right here. So where they overlap at is this number right here, 0.0851. So if you want z equals 0.86, go to the 0.8 row and the 0.06 column. Okay, and we're getting the overlap is right here, 0.8051. Okay, so 8051, 8051. And we already had the other one from the last problem, which was 0.0228. So then I go to a calculator, I subtract those. So 0.8051 minus 0.0228. And I get 0.7823. Okay, so that means that the area under the standard normal curve between those two z-scores is 0.7823. So probability that a song is 2 to 4 minutes long is 78.23%. And the last problem here, I'm doing 1 minus the CDF that I just looked up on the last problem, so it's this one. And that is going to give us minus 0.8051. Okay, so 0.1949. Oops, forgot it's not copy and pasting. Okay, there we go. So probability for a song being less than 2 minutes was about 2%. Song being 2 to 4 minutes, about 78%, and song being more than 4 minutes was about 20%. And those areas all look roughly like they do in the picture, so cool. It's good to sketch your own pictures if you can, to try to get a kind of a rough estimate of what you're looking for. It can help your thought process. All right, so the next question is 100 most popular songs on Spotify in 2022. So the tempos were approximately normally distributed. Mean of mu is going to be 120, standard deviation sigma 29. And we want to know what is the probability that a randomly selected song has a tempo of 100 to 150, more than 150, or less than 150. So here parts A, B, and C are scrambled up from what they were in the last question, but it's still the same thought process. So you're going to calculate two z-scores, z1, z2. Okay, and these are going to be for the two tempos that were of interest, which are 100 and 150. Okay, so we're going to use x1 and x2. And we're going to use the same mu and sigma. So my x1, that is the first tempo that I was interested in, so 100. And then my mu is 120, sigma is 29. And my second tempo of interest was 150. Mu is still 120, sigma is 29. Okay, so I go to calculator, find out what these z-scores are. Okay, so these are the z-scores that I'm getting. So for the between question, I'm going to do CDF of the larger z-score minus the smaller one. Okay, and I get the CDF from my table. So I'm going to look that up in a minute. For the more than question, I'm going to do 1 minus the larger CDF, or the CDF for this 150. So that is going to be 1.03. Okay, and then for the less than question, I am doing just regular CDF of the z-score for that data value, which was this one. So negative 0.69. All right, now I'm going to go to my table. I'm going to look up those two CDF values. Okay, so first one is for 1.03. Okay, so I'm going to the 1.0 row, and then I'm going over to the 0.03 column, which is this one. So I'm looking at 0.8485. 0.8485. 845. Okay. Now the CDF for negative 0.69. I'm going back to the negative side. So negative 0.69. So negative 0.6 is here. And then for the 9 decimal place, that is the leftmost column right here. So leftmost column is going to give me 0.2451. 2451. Okay. And now I just go to a calculator, subtract those two values. 0.845 minus 2451. Okay, so 0.6034. You can convert that to percentage if you want to, or just leave it as a decimal. Either way is fine. So now that we have those both looked up, the others should be a little faster. So this was 0.8485, and this one is just plain old 0.2451, 24.51%. All right. You might want to double check, make sure that these three probabilities add up to 100%. That can be a nice little way to check your work. Since we covered every possibility of what the tempo could be, it has to fall into one of these three categories. So they should add up to 100. Great. Next question. Assume the runtimes of all movies in IMDb's database are approximately normally distributed with a mean of 94, a standard deviation of 38. What percentage of the movies are shorter than 1 hour, 1 hour to 2 hours, 2 hours or longer? So again, it's our three-part question. So we're going to need two z-scores. I'm just going to copy and paste this time and kind of use the template that I've been using before. But I will erase the actual numbers. So my two data values this time are for 1 hour and 2 hours, but be a little bit careful because the mean and stuff are in minutes. So it's going to be 60 minutes and 120 minutes. Okay. So this will be 60 minutes. And this one is going to be 120 minutes. And the mean for both is 94. And standard deviation is 38. Okay, so we go to the calculator, plug these in. Okay, so these are the two z-scores that I'm getting. And now how do I use these to get my CDFs? So shorter than 1 hour, that's just going to be, so for any shorter than or less than, it's going to just be the regular CDF. And then you pick the z-score that goes for 1 hour. So the one for 1 hour is this one. We used 60 minutes. Okay, so negative 0.89. 1 to 2 hours, so this is where you're going to use both z-scores. You're going to do the larger CDF minus smaller CDF. So larger CDF always comes from larger z-value. Okay, and then finally the something or longer, something or greater is going to be 1 minus. And then you're going to 1 minus the CDF for that data value of 2 hours. So that is this one. So 0.68. All right, now we have to look up the CDF values from the table. So we'll show you one more time. Oops, nope, okay. Negative 0.89. Okay, so we go to the negative side, negative 0.8. And second decimal was 9, so we are looking in this column right here. So leftmost column, that's going to be 0.1867, 0.1867, 0.1867, okay. If you want, you can convert to percentage or leave it as decimal. I don't really care. Now for 0.68, so we're going to flip to the positive side, go to the 0.6 row, and the second decimal was 8, so we're looking in the second to last column here. Second to last column is going to give us, oops, 0.7517. 7517. Okay. So minus the last one was 0.167. All right, get a calculator out, subtract those. 7.86. Okay, and we're getting 0.565, 56.5%. And for the last one, we are doing 1 minus 0.7517. Oops, 7517. Okay. 2483. Okay, 24.83%. Okay. It looks like these should add up to about 100%, so I'm feeling comfortable about that. Last one, exact same way, 2 z-scores. Put your z-scores into your CDFs. Make sure you did the right way each time. CDF 1 minus CDF or CDF minus CDF. So let me copy my little template again. Okay, take out the numbers. All right, so here we're doing temperatures, And the two temperatures that are of interest are 98 and 99. So those are going to give me my two z values. So x1 is going to be 98, x2 is going to be 99. Looks like mu for both of them was 98.6. And sigma for both of them was 0.6. Plug that into a calculator and we get -1 exactly, so I put 2 zeros after the decimal, and then 0.67. So for less than or something or below, you're just going to do regular CDF for that z value. And that was the one that went with -1.00. For between, you're going to do larger CDF minus smaller CDF. So it's going to be the +1 minus -1. And for greater than, you're going to do 1 minus CDF. So the CDF for 99 was 0.67. All right, last time I'll show you guys the table again. So we go to -1.00, so negative side, -1 point. Okay, so this one. And then the row, or sorry, the column is going to be for 0 on the second decimal. So rightmost column. So we're looking at 0.1587. 1587, or 15.87%. CDF for 0.67, so we look at the positive side, 0.6, and second decimal place is 7, so we're looking at this column right here, so third to last one. It's going to be 0.7486, this one. 7486, and then we're subtracting the CDF from the last part. Put that in a calculator. .5899, or 58.99%. And then for the last one, the CDF was 0.486. Okay, so that's going to be 0.2514, 25.14%. All right, and I won't tell you guys what the extra credit is. I always think that if you're going to get more than 100%, it should be for something you didn't actually learn in the class. So more than 100% means you learned more than I taught, right? Okay, if you have any questions about these solutions, send me an email or come to office hours.